Welcome everybody. In our last video of op-amp, we had discussed about its introduction and the inverting op-amp. Today, we are going to discuss about the non-inverting op-amp. So what exactly is a non-inverting op-amp? In this case, we are connecting an input signal to the positive terminal or the non-inverting terminal, and the negative terminal is simply grounded. So, if we study the circuit diagram of a non-inverting op-amp can be represented as follows. The positive terminal, here we are applying the input, let us name it Vin, and we are grounding it. And the negative terminal is grounded, and it is provided with a resistor R1. If this is the output V0, we are providing a feedback to the inverting terminal by a feedback resistor RF. So, this is the circuit diagram of non-inverting op-amp. Now, let us draw the equivalent circuit of non-inverting op-amp. In the equivalent circuit, here, if this is the positive terminal or the non-inverting terminal, we are applying our input signal here. It is our input signal, and this is our inverting terminal, and we obtain our output here. The feedback resistor RF is connected here, which is again connected to R1 here. So R1 is connected and it is finally grounded. Now, a terminal from the inverting terminal is connected at this point, and let the voltage at this point is denoted by Vx. Now, according to the voltage divider rule, we can know the voltage Vx is given by Vx equal to R1 divided by R1 plus Rf multiplied by V0. Now, as we have studied earlier, when the feedback is applied to the negative terminal or the inverting terminal, we obtain a virtual ground condition. And we know that in virtual ground condition, the voltage at plus terminal or V plus will be equal to V minus. Now, V plus will be equal to V minus, and again V plus is what? V input. Now we can write this is equal to what? V input, and our V minus at this point is also equal to Vx. So comparing our above conditions, we can now write that the Vx is equal to V input. Now using this value in our equation, we can know that V input equal to R1 divided by R1 plus Rf multiplied by V0. And now V0 divided by V input becomes R1 plus Rf divided by R1. Now, the output voltage and input voltage, its ratio is called the gain of op-amp, and this is called the closed loop gain. We are writing it ACL, which is equal to, when we divide this R1 by R1 equals to 1 plus Rf by R1. Now we are calling it closed loop gain because the feedback is applied to the inverting terminal. So here the closed loop gain is equal to 1 plus Rf by R. Now, let us say some of the advantages of the non-inverting op-amp. As we know that here the input signal and the output signal, the phases are equal. So whatever signal we apply at the input, the same signal that will be obtained, that is in same phase. Now another advantage will be that the input impedance becomes infinite. So how is that possible? The input impedance we denote it as Zin. It is given by Zin equal to Vin divided by In. If we look at the circuit, clearly in this case, the I input is equal to 0, and when I input is equal to 0, obviously the Z input will be infinite, or the input impedance will be infinite. Now let us discuss one application of this non-inverting op-amp. And we know that the non-inverting op-amp is used as a buffer. So what is a buffer? A buffer is also called as voltage follower. Now let us draw a circuit. In a voltage follower, if this is the negative and this is the positive terminal, and this is the feedback, this is the output signal, the output signal is directly connected to the negative terminal and the input is applied here. And in this case, we get the RF equal to 0 and the R1 equal to infinite. And when RF equal to 0 and R1 equal to infinite, we get that the V input will be equal to V output. That is, whatever input we are providing to the op-amp, the same output will be obtained, and hence this is called a voltage follower. So hope you understand better in this video. So thank you for watching. In our next video, we will discuss about the applications of op-amp, that is adder, subtractor and all. Please like and subscribe our YouTube channel.